Hello, what I learned today, and today's topic is Google RPC, GRPC. So, sometime as a software engineer, I need to know how to communicate between process if they are running on the same system. It could be a client server on the same system called intra-node communication, and I need to know how to communicate between the client and server, and if the client and server are running on two different nodes. That is called inter-node communication. I also want to know how in software I can talk synchronously between two entities, and I also want to know how I can talk asynchronously between two processes or services. GRPC. GRPC is an open source framework, and it helps us to build high performance language neutral communication system. It allows application to make remote procedure calls RPC efficiently and securely. What is GRPC? So let's say imagine you have two programs running on two different machines. One program need to access the functions or service that is provided by others. So now GRPC actually provide all the framework and facilities to have this communication where one program can call the function or service of another program, and it will feel and look like you're calling that function locally. However, that function is not available local, but on the remote end that function is available. This eliminates the need of complex networking protocol. We don't need to understand how socket and everything else is working, and it ensure that you exchange the data very efficiently. Why use gRPC? Again, there is multiple use cases, but gRPC provide lot of performance benefits because it uses protocol buffer, which is language neutral. It is compact and efficient, so data transfer is very fast. Language neutrality provide code generation tools for various languages. So it support multiple languages, and then generation of code is very easy for multiple language. And then it has couple of rich features like unary RPC, where a client can send a message and server response. Server can send multiple messages to the client called service side streaming, and client actually can send multiple message or maybe sensor data to the server, like uploading a file or something. So that is called client side streaming. And then we can also do both side streaming by bidirectional streaming, where both ends client and server can do sending a lot of data to each other. Now let's talk about the practical use cases that where we apply the gRPC. First is of course microservice communication, where there are multiple services, and then these multiple services, they can be distributed across multiple nodes, and we want to communicate between these services. So microservice communication. Mobile app development, everybody has a mobile app that talk to the mobile app server, and gRPC can play a very vital role to communicate from application that is running on mobile to the server. And then API development. So gRPC can be used to define and expose API to various services. So a server can host multiple services, and then it can expose its service via API using gRPC, which is a very reliable and secure connection. And now let's talk about the synchronous and asynchronous RPC. Synchronous RPC, where a client wait for the server response before it continue execution. So it's like wait for server response as soon as it call the function, which is very much similar as in traditional programming function call. We call a function and immediately it wait for, or we immediately get the return of that function. And then in asynchronous RPC, where client sends a request to the server, and then it doesn't wait for the server response but continue execution. Server can at any time can respond, and client will accept that response and process it. So that is called asynchronous communication, where it is not always call and wait for immediately for the response. Now, why this GRPC is so convenient, so efficient, and the magic behind is the protocol buffer. They use protocol buffer. In this one, you just have to define a .proto file where you define your service method and what are the data that you want to exchange, what is the structure of request and response. You define that in .proto file, and then you use that .proto as an input to the a provided tool called proto C. You can say protocol compiler, and then that proto file that you provide as an input, and which language you want to generate the files, you provide that as well, and it generates the code that has all the class and supports for supporting the RPC. uh, and then you have the efficient boost, because it's in server and client both uses the same proto or same data structure. We don't need to decode or encode or converting and parsing the complex data from one to another one. And that's how the protobuf buffer are compact and very efficient. Let's talk about one example to understand it a little more clearly. So first of all, you have to, as I mentioned, you have to create a .proto file. In that file, you have to tell what minimum version of proto buffer you are supporting. So here I'm using proto 3, and then I am defining a service called calculator that has one service inside it or function inside it that takes a RPC. This is a RPC function. It actually RPC add, so that means it is the name of the function is add, and it actually takes the some request type of input and returns a some response type of output. If you look at the further into some request, it is a two numbers, and some response is a response of integer that is the sum of the two numbers. So this is the type of the data structures that function takes or service takes, and then you just provide that .proto to the proto C, and then it generates all the required file. In this case, since I created a calculator.proto, it will create calculator underscore pb2.py for Python, and calculator underscore pb2 underscore grpc.py that contains all the necessary classes and functions. And then using those files, self-generated files, you will write some code to create a server. So here I am just showing the implementation of server, which is having two functions, synchronous and asynchronous. If you see, it created a class called calculator servicer. It has a function called add, and it has a asynchronous add as well. If you see inside that, it's just like adding two numbers and then returning the response. And then if you see at definition serve function, it actually spawn a maximum worker 10 threads using the concurrent module of Python, and then it actually add the service to that particular GRPC object, and then you open a port, a local port to your machine, where this the server will always publish the data or listen to, and then you start the server. If you look at the client program, in the client program, you just have to connect to the server, and then you call the function with the grpc object. So you create an object via channel and create an object, and then you create a request in the format of request data structure, and then you just call the add function to collect the response. Similarly, you can do the asynchronous add as well. Here you just have to not to wait immediately, but in the future you can get the results. So this is the client and server, very simple program to achieve a remote procedure call, uh, and there is no too complex code that you have to write. That's all for today's lesson. Hope you like it, and that's conclude our what I learned today, GRPC. Thank you.